For today's notes, you will need in class 66. We are dealing with part 3 of standard 15, which focuses on finding surface area. Today we will be dealing with what is called a right cone. So as a review from our previous lesson, surface area is the total area of all surfaces of a geometric solid. Specifically, when we're dealing with cones, the formula that we use for surface area is pi RL plus r squared. Pi RL calculates the surface area for the slanted part of the cone, and then pi r squared is for the circular base of the cone. Thinking about r, that's going to represent the radius of the base of the geometric solid. L is going to be the slant height, similar to what it was with pyramids. That describes the distance between the apex and the base edge. And then capital H, which is not in our formula today for surface area, but will be important to use to help us find parts of our formula, is the actual height of the cone. That actual height is connecting the apex and the center of the base, just like it did in pyramids. Okay. Testing our understanding of that terminology, we are going to shade the face that should be used as the base. So I'm going to continue to use yellow for that. And then we're going to highlight or draw in a distance that represents the radius. That's going to be the R part of the formula. And then we're going to have another distance that represents the slant height. That's going to be the L part of the formula. So when we're looking at a cone, the circle is the base of the shape regardless of where that circle is located. So it might be the bottom, it might be the side. If we flipped it upside down like an ice cream cone, then it would look like the top of that solid. The radius is found in that circle, starting at the center and traveling out to an edge. So it can go in any direction, but we usually draw it in either to the farthest point away in the circle, either above or below in this case, or left or right in that case. But we could also draw it kind of like to the front edge, and it would look a lot smaller, but it would still be R. It would still represent the radius. The L, slanted height, starts at the apex and travels to the base edge. So it actually kind of looks like the side of the cone, although that side is not an actual segment in a real cone, but that would be the slanted height. On this one, I'm going to draw it down here at the bottom so it connects to the radius, but it could also be drawn into the top, or it could be drawn in to connect to the edge somewhere else as well. And then just for help visualizing, this distance here, the last side of that little right triangle would be the capital H height from the apex to the center of the base. So in this triangle, be from the apex down to the center of the base, which gives us the opportunity then to find missing slant heights or to find missing radii by using a right triangle along with our Pythagorean theorem, similar to what we did with pyramids. So that right triangle has a capital H connected to the radius, and then that slant height is the hypotenuse across from the right angle. So we'd have the slant height in the place of the C for C squared, and then our actual height through the middle of the cone, and then that radius would be the A and the B part of that formula. Okay, continuing on, we're going to try to put that into action and see how it goes. Since the goal is surface area of a cone, we're going to start by writing down our formula, pi RL plus pi r squared. Looking for the radius, we know that's going to be connected to the center of the cone. So since 8 is the all the way across distance, the radius will actually be 4. And then the only other thing I need is that slant height, and it looks like they've given that to me over here on the right side of the page. So I'm ready to take all of that information and plug it in. Pi times the radius of 4 times the slant height of 10 plus pi times the radius of 4 squared. The goal for these is to give exact answers. So I'm going to leave pi out of the calculations and just do 4 times 10 for 40 pi, and 4 squared is 16 pi. Since those both include pi, they are considered like terms, which means we can combine them together. 40 plus 16, and then centimeters that are squared will be our units for that surface area.